Here we are being asked to take the derivative of x to the fourth plus 3x to the fifth plus 3. Now this is an example of power rule. That's x to the n, or we want to take the derivative of it. That's n x to the n minus 1. So we're going to use this rule here. So by power rule, the derivative of x to the fourth is 4x cubed. And so we bring the 4 down, we subtract 1 from the exponent. We're going to do it again here. It's 5 times 3, that's 15. And we subtract 1 from the exponent, that's 4. Now, what do we do with constants? We just take them away. It's plus 0. If there's no x and you have a number, it's just 0. This is the derivative. We have a fraction-like function that we need to take the derivative of. Now, don't get too scared. We just follow this rule here. It's called quotient rule. You just go low, that's this, low times the derivative of this, it's h, this is h and this is L, minus h by itself times the derivative of the bottom function all over this bottom function squared. This will give us the derivative of any sort of function like this. So let's plug it in. We take low, x squared plus 1 times the derivative of the high. So if we do product rule, the exponent up here goes to 0. And when there's a 0 in the exponent, it always goes to 1. Always. Let's do this times x times the derivative of the low, which is 2x. Again, coefficient here just goes to 0. All over x squared plus 1 squared. So this is an unsimplified version of the derivative, but I am going to simplify it. So let's do x squared plus 1 minus 2x squared all over x to the fourth plus 2x squared plus 1. And that roughly equates to negative x squared plus 1 over x to the fourth plus 2x squared plus 1. And this should be our simplified derivative. Here we want to take the derivative of a trigonometric function. Now these all have pretty predictable derivatives. In this case, the derivative of sine is equal to cosine of x. Just goes down 1. But we have this 2 here, so what do? We are just going to take this 2, move it out to the front. So the derivative of sine of 2x is 2 cosine 2x. You don't do anything to the 2 in here, you just bring it out. And that is our derivative. Here we are trying to take the derivative of sine x over cosine x. Now, some of you might be thinking, we have to use quotient rule here, but sine x over cosine x is equal to another trigonometric function, that being tangent of x. So we have to take the derivative of tangent of x to get the derivative here. Now, you may have already learned this, but the derivative of tangent of x is just secant squared of x. And that is our derivative. It's that easy. Here we have another tricky one, the derivative of 1 over x. Some of you, again, are probably thinking, oh, we got to use quotient rule again. In reality, this is actually one of the strangest derivatives out there. The derivative of 1 over x is actually ln x, the natural log of x. So if we say put all of this in the exponent of e, is e to the ln x, it's just equal to x. These two cancel out. It's just x. Here we have a very tricky looking function. It's not as bad as you think. We do the same thing as we were doing with the sine and cosine derivative we were taking earlier. We take the derivative of this, multiply it by this, plus the derivative of this times this. So let's do that. Derivative of 4x is just 4 times sine x, sine of x, plus the derivative of sine x, that's cosine x, times 4x. And this is our derivative. Let me make it a little better for you guys to look at. That's 4x cosine x is equal to y prime. Another function. Now, go ahead and try this on your own. Give it a little pause. Okay, so let's start. The derivative of this, that's 9x squared plus 4 cosine x is equal to y prime. And there we go, we have our derivative.